So two object problem. So we have two people standing 100 meters away. The one has a velocity of 10 meters per second. The other one has a velocity of negative 15 meters per second. And we want to know when they will meet and how much time will it take. All right, so first way to do it, I start from the easiest, is from the motion diagram, saying, all right, so this first does 10 meters per second. So in 1 second, he will do 10 meters, while at that second, he will do 15. So he will be here. Now in the next second, he will do another 10. I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 90, and they were 100. So in the next second, he does another 10, he does another 15, and then he does another 10, and he does another 15. 3 seconds so far. The fourth second, he does another 10, and he does another 15, and they meet. So they need 4 seconds, all right? Now, could I do it with tables? Yes, I could. Saying that, so as time passes, let's see the position of each one of them. So at time 0, he is at position 0, while he is at position 100. Maybe I should add the velocities. What do you think? So V1, 10, 10, 10, 10. So he starts from 0, while the other one has a velocity of negative 15 the whole time. And he starts 100 meters away. So he does 10 meters and then 20, 30, 40, while he does 100 minus 15 is 85, check on me. And then in the next second he goes to 60, all right? No, it is 70. And then after another second, it goes to 55, and then at 40. So we see that at the fourth second, they are at the same position. All right? Now, can I do it otherwise? Of course. We can do it as with equations, but how do we start? So we have two objects, each one does its own motion. So I do have for each object the formula for its own position, right? If I do this for the first object, the acceleration it has, the velocity it has, initial and final, the initial position, the final position. So I don't know the time. I know that there's no acceleration. Velocity is 10 the whole time. And he starts from 0. I don't know the final. So using the equation this, I do know that this is 0. I know that all this term is 0, because when acceleration is 0, the whole term is 0. So for the first one, x1, I do know that his velocity, let's call it 1, it's the same, times time will give me the distance, if only I knew time. Now the same thing happens with the second person. Sorry, there are people. So doing this again, I do find, I don't know time, I know there's no acceleration, this is negative 15 the whole time. The initial position is 100 and I don't know the final. So by using the same equation, the only we have, there's no acceleration, so this term turns 0. And what we have is that x2 equals the initial position, which is 100, plus v2t. And this is the formula that gives the position for the second object. Now, I need some space. Now for the first one, we said, I know that it's v1t and the v1 was 10 meters per second. Now for the second one, it was 100 plus v2, which means it's 100 minus 15t. And I do know that they need to meet their final position should be the same, so they need to meet. So for x1, I have 10t equals 100 minus 15t. So 10t plus 15t equals 100. 25t equals 100. And I do find that I didn't use the units just because I wanted to make it simple here, right? Now, if I had used the units, I would find here meters and I would find here meters per second. So the time would be 4 seconds, right? So I did find the same time. Now, there's one more way. Every time we have two objects, we can use something that it's called the relative velocity. The relative velocity is found by subtracting the velocities two objects have. So when I subtract, what is the idea? The idea is that instead of thinking of two objects having with a velocity v1 and v2, it doesn't matter, can be in all cases, I can consider as the one not moving and giving all of its velocity to the other. This is what happens in us when we are traveling. So let's say that I'm traveling in an airplane, right? So I'm traveling in an airplane and another airplane comes this way and I say, boy, it goes fast. Well, what do I actually think? I think of, so if my airplane moves with a velocity of 100 and the other one moves with a velocity of a negative 100, I see myself as not moving. So I consider that my velocity is 0. And I see the other as moving with negative 200. So what I actually do, I subtract my velocity from both velocities, right? Because if I consider myself as not moving, it's like subtracting the actual value, turning it to 0. And I have to do the same to the other velocity. So if it's 100 and negative 100, by subtracting 100, I turn to 0 and this turns to negative 200. So I see it going fast. Now, if we're moving, if we're moving in the same way, right? So I am moving with 100 while this airplane moves with 150. What do I see? I see myself as not moving, and I see the other moving with 50, right? That's what is going on. That's what we call the relative velocity. So in this case, if what this person sees is that he sees himself as not moving, okay, everything else moves, not him, right? When I move, the world moves around me. I'm not moving, right? So he sees himself as not moving, and he sees him as moving with negative 25, right? Which 25 looks like this. Is that a coincidence? No. So what actually happens? If we consider the one as not moving because he looks the whole situation from his point of reference, so he sees himself as not moving and sees this as moving with negative 25, right? So actually these 100 meters, okay, are happening to that direction. So this person will have a displacement of negative 100 meters with a velocity of negative 25. So the time for him to do the distance of negative 100 meters with his new relative velocity of negative 25 meters per second is 4 seconds. But just because I didn't say anything, what is this? Okay, so you can actually consider this as meters over 1, having a denominator of 1, and do this. So what actually happens is that the time is 4 meters second over meters time 1 meters go, and you find the seconds, right? The denominator of the denominator turns into numerator, right? So these are different ways of doing the same thing, finding the same value. Now, the motion diagram is easy for easy cases. For harder cases, it's not.